Okay. Un-SHO. A simple harmonic. I don't know how to. Yeah. Has an equation of position in meters of x equals, okay, 9.50 meters sine 1.62 t. What is its position, velocity, and acceleration at 9.25 seconds? Ooh. Okay. Well, we can figure this out, okay? So if we do this, right, if we go x is equal to x naught sine omega t, right? Okay. So, and that's one of our equations in 9.1, right? Okay, so that means that x naught is equal to 9.50. That's our amplitude, right? And that also means that omega is 1.62 radians per second, right? We can just read that off of there, right? That's where omega is, there's the number 1.62, and where the x naught is, the number 9.50 is there, right? Okay, so to answer what is its position, we're just going to use this formula. Now you have to be in radians. You must put your calculator in radians and then just do this calculation. X is equal to 9.50 sine 1.62 times 9.25, and see what you get. But first, on my calculator, I know that I'm in degrees, so I'm going to go down. I'm going to go, what's mode, and then I'm going to go down a couple, hit enter. Now I'm in radians, clear. Okay, so now we're set. I'm going to go sine of pi. Let's just double check. Ooh, sine of pi of 0. Okay, so 9.5 times sine 1.62 times 9.25, right parenthesis. And my x is equal to 6.28529 meters. All right, so now the question is, what is the velocity at that point, right? Now, resist the urge, do not use the v equals plus or minus w square root of whatever. We could do that and we could find the speed of it, but we couldn't tell whether it was positive or negative, okay? So if we want the velocity, we actually have to use the corresponding velocity equation, right? And the corresponding one that goes with this is that v is omega x naught cos omega t. And this comes from the chain rule. So people who are studying calculus, right, there it is, right? You're going to do the chain rule on this, and it's one of the simplest ones, right? Derivative of sine is cosine, and then the derivative of the function inside is just omega, right? And it comes out. Okay, so now we can figure out the velocity. So the velocity is going to be omega, right? Omega x naught cos omega t. And again, I still want to be in radians, right? So that is 1.62 times 9.50 times cos 1.62 times, our time is 9.25. All right, let's see what it says. Okay, so 1.62 times 9.50 times cos 1.62 times 9.25, right parentheses. And I get negative 11.54. meters per second. So that is our velocity, right? Okay. Now, how do we figure out the acceleration? Well, the acceleration is negative omega squared x, right? Okay, now let's just plug that in. So that's going to be the opposite of 1.62 squared, and then our x is 6. We're going to use that, right? 6.28529. Okay, so here we go. The opposite of parentheses 1.62 squared times, and then I'm just going to grab that number from up there. And I get negative 16.5, 16.495 meters per second squared. Okay. Here's where the units come from. This has the units of meters. This is radians per second, right? Okay, when you square that, remember radians really aren't there. They're just a placeholder kind of, right? They don't have any units. And so this is 1 over seconds squared times meters, and you're going to get meters times seconds to the minus 2. Okay, so there that is. Now let's just imagine that you understood calculus, right? Isn't the acceleration just dv dt, right? Well, yes, it is, right? So if we take the derivative of this, right, of this function, it's just the chain rule again. The derivative of cosine is negative sine, right? So you get, and then the omega comes out in front, so you get omega times omega x naught negative sine omega t. And that becomes the opposite of omega squared x naught sine omega t. Now we really haven't made our life any easier, but now we have a function that actually creates the acceleration, right? Totally disregard this. This is the answer. This is how you should get it. I'm just showing folks that know calculus how we could get it, right? So this is the opposite of 1.62 squared times 9.50 times sine 1.62 times 9.25. Let's try that. The opposite of left parenthesis, 1.62 squared. Okay, times 9.5. It's always 2, right? Okay, let's see, times sine of 1.62 times 9.25. It's pretty exciting. I get exactly the same thing because, of course, this is just going to give us this, right? Okay,